All right, let's dive right in. Today, we're going to tackle something that messes with almost every C# developer at some point. This whole async versus multi-threading thing. What's the real difference? Let's find out.
I hear this phrase all the time, especially in interviews. Everyone feels that async means multi-threading. It's this gut feeling people have, right? That when you type async and await, you're magically firing up a new thread in the background to do the work.
But is it? Is that what's actually happening under the hood? Or is async just a cleaner, fancier syntax for creating threads? Well, that's the big myth we are here to bust today. So let's get into our first section, the async means threads myth. My one and only goal here is to prove to you that asynchronous code, by its very design, is not supposed to create new threads. Okay, this slide right here. This is the core of it all. You've got to understand that async is all about usability. It's about keeping your app responsive so the UI doesn't just freeze up while it's waiting for a file to download. It's for non-blocking operations. What it's absolutely not about is raw performance. It's not trying to create more threads or use more CPU cores to make some heavy calculation finish faster. It's a totally different... All right, talk is cheap. Let's actually prove it. It's time for an investigation in code. Put on your detective hats, because we're going to go hunt for this mysterious new thread that async is supposed to be creating. And here's our main suspect, a super simple async method, but with a task.delay of 60,000 milliseconds. That's a full minute. Now, this is exactly the kind of place where you'd expect a new thread to pop into existence to handle that long wait, right? Otherwise, the app would just lock up. So we fire up the debugger, we put a breakpoint right before that await line, and we take a peek at the threads window. And what do we see? Just one. A single thread. Our main application thread just doing its thing. Nothing to see here yet. And boom, we step over the line. The code hits await task delay. That 60-second timer is now ticking. But look, the application is still totally responsive. It hasn't frozen. So that waiting is happening somewhere. But where is it happening? We look back at our threads window during that entire 1-minute wait, and what do we find? Still just one thread. No new thread ever appeared. This is the smoking gun, folks, the key piece of evidence. The long wait is happening, but our thread count hasn't changed at all. Which leads to the million-dollar question. If there's no new thread, then how in the world is this even possible? How is the application not completely frozen while it's waiting for that minute to pass? The answer isn't a thread. It's something way cleverer. It's a compiler trick. Let's pull back the curtain and talk about the state machine secret. So what is a state machine? Well, when you write an async method, the C# compiler secretly rewrites your code. It chops it up into little pieces or states. And the beauty of this is that a single thread can then run these chunks one at a time, only when they're actually ready to do something. Here's how it works in practice. First, the thread runs all the code before the await. Simple enough. Then, when it hits await, here's the magic trick. It pauses the method and releases the thread. It doesn't block it. It sets it free to go do other useful work. Then, once that background I/O operation is finally complete, the state machine says, okay, we're ready, and it grabs an available thread to resume executing the rest of your method. But, and this is a big but, there's a little twist that often adds to the confusion. It's why some people still think new threads are involved. Let's look at the synchronization context twist. So check this out. In a simple console app, if you look at the thread ID before the await, it might be, say, thread ID 1. But after the await finishes, whoa, look at that. The rest of the code is running on thread ID 4. It's a different thread. Now, this happens because console apps don't have something called a synchronization context. So when the work is ready to resume, the system just grabs any available worker thread from the thread pool to finish the job. But in a UI application, like WinForms or WPF, it's a totally different story. They do have a synchronization context, and its entire purpose is to make sure that after an await, the code gets sent back to the original UI thread. This is absolutely critical to prevent weird UI bugs, and it really drives home the point. The goal is to manage work efficiently on the main thread, not just to spin up new ones. Okay, so we've busted the myth, we've seen how the magic works. Now for the most important part, the practical takeaway. Let's get to the final verdict on async versus threads. This table says it all. The purpose of async/await is for non-blocking operations, waiting. The purpose of a thread is for parallel execution, doing two things at once. Async doesn't create a new thread, it borrows one from a pool. A new thread? Well, it creates a new thread, which is expensive. That's why async is low on resources and perfect for IO-bound tasks, while threads are resource-heavy and really only for CPU-bound work.
So here's your cheat sheet. When do you use which? Use async whenever you're waiting for something outside your program. Calling an API, querying a database, reading a file. You're waiting on the network or the hard drive. Use a dedicated thread, or more likely, task run, when your own CPU is the bottleneck, when you're doing heavy-duty calculations or some intense background processing. I just love this analogy. It's so perfect. Using a new thread for a simple, non-blocking I/O operation is like using a saw to cut an apple. I mean, sure, it'll work. You'll definitely cut the apple, but it's just massive, ridiculous overkill and super inefficient. You need to use the right tool for the job. And look, just to help you really nail this down for your next code review or technical interview, here are some huge mistakes to avoid. Don't ever say async is just a cleaner way to do multithreading. It's not. Please never use thread.sleep in an async method. It's a blocking call that freezes your thread. Use Task.Delay instead. And for the love of all that is holy, avoid async void unless you're writing an event handler, because it's a black hole for exceptions. So if you forget everything else we talked about today, just burn this one sentence into your brain. Threads are for parallel execution. Async is for non-blocking execution. They solve two completely different problems. At the end of the day, async isn't a new type of thread. It's a completely new and much smarter way of thinking about waiting.